Hello, hello. Total Development Lab back again with another video. And today is a bit different. Today, we will be using the JetBrains IDE for the Rust implementation that we have here. Now, a little bit about it. This is called the Rust Rover. Again, it's by JetBrains. It's from the family of um, Java IDEs. So think of Eclipse and IntelliJ, all these type of things. But without further ado, let's get started, right? And today we will be implementing the Vernam Cipher as promised. So let's get started in our usual way. At the lab, we see here that we have a terminal. We're given a terminal in this Rust Rover IDE. So let's go ahead and use it. As you can see, we are in our playground, Rust playground. And let's use the total CLI to create a Rust project named Vernam Cipher. As you can see, we went ahead and created it. And here we go. Inside our folder, we have the Vernam Cipher. Perfect. Let's go into the source, then the main. Cool. And as you can see here, we now can start writing our code. So we can go ahead and keep this main function. Let's get rid of the hello world. Let's keep it a to do for now. And let's go ahead and add some functions for our cipher. So let's go ahead and start off with a helper function, right? So let's say helper function. We're going to name it pair text, right? And as you remember from the presentation about the Vernam cipher, we need to convert all our plain text or strings into a vector of numbers before we can go ahead and encrypt or decrypt. So let's do that here. In Rust, we could just say fn for function, and then obviously name it prepare text. And then that function takes in a string called text. And it's a reference to a string. And it needs to return a vector. That vector needs to be of string or of numbers, right? So U8. Perfect. Now, let's go ahead and return that parameter text. And then we're going to convert it to uppercase. And then convert it to a character array. And we're going to filter that character array by the characters. And we need to check if each of these characters is an ASCII character. So we can do that in Rust by this helpful function called isASCII. And it's alpha. We ask, is that character an ASCII alphabetic character? And if yes, we want to then grab those characters or filter out for them. Basically, if it returns true, it'll move on to the next piped or piped function, which is the map. And then we need to loop through that map like each character, then ask, is that character, or we want the characters to, all the characters to be looped through and returned as a U8. And we use this syntax for the alphabet. Then at the end of this, we want to just collect or call the collect function. Perfect. And perfect. As you can see, our function here is one line. And I like how the Rust rover catches that this function doesn't exist and we need to change it. And it's marked as red. And as soon as we change it, it changes back to blue, which is very helpful. Very, very helpful. But nonetheless, let's go ahead and start our encryption function. Now, to do this, we need to go ahead and create a public function called Vernam encrypt. And our encrypt should return a string, or we are expecting to return a string. And in that Vernam encrypt function, we want to expect a parameter of the plain text, and it needs to be of type string, right? A reference to a string. And then we also need to expect the parameter key, and that key will also be we're expecting it to be a string. If you're having trouble, look back at our overview, and as this might get a little bit difficult to understand, and that overview goes over all of what we're doing here. Cool. And now let's dive in deep into our function. And first thing to do is that we need to convert plain text and key into numbers from 0 to 25, right, for the alphabet. So we can do that by saying let, or creating a variable called plain text numbers. And in that plain text numbers variable, we want to use our helper function, prepare text, to go ahead and give us that array of integers from our string of characters, or the original text to encode. Great. So that being the case, let's now do the same thing for the key, and then we'll do the same thing and we'll use the prepare text helper function again. And we also want to check that our key is not empty, right? So let's ask in our code to check for if a key is present in the parameters. And if it's not, we return or we call an error to the user saying that the key must contain one letter. We can do that in Rust in a quite easy way. And if you're familiar with testing libraries, this should be easy for you. But as we know, the cipher cannot work without a key, right? So let's call the assert. And in this assert, we want to essentially say if our key is not present or it is empty, say key must contain at least one letter. Perfect. Next thing to do is go ahead and encrypt our plain text, right? So let's use that variable plain text numbers and then iterate through them and then enumerate through that iteration. And then let's call the map function. And then in that map function, we want to pipe in the index. We're using a tuple here, right? The index as well as a reference to the plain text number or the plain text value, excuse me. And through that, we can now essentially repeat the key when it is shorter than plain text. And we can do that by saying let key value equal the key number at the index, and then we use the modulus to loop through that and always repeat the number. Perfect. And just because I don't like how this red underline is coming up, let's call collect at the end. Perfect. Anyways, so let's also go ahead and do our encryption. And we could do that by saying we're creating a variable called let encrypted value equal the plain text value plus the key value modulo the number or the amount of letters or the amount of letters in the alphabet. And that looks like that. Perfect. And then we now want to essentially return, or when this map is being generated, we want to return that encrypted value plus the binary representation of the alphabet or the capital, right, as a character. You can do that as so. There you go. That is our encrypt function. Now, our decrypt function is quite similar, but there's just a bit of a difference. So let's go ahead and create our comment here and use public function Vernam decrypt. And that decrypt function will take in our cipher text as well as our key and then return a string. And that should work just fine like this. But we could also now go ahead and take our it's essentially going to be the same thing here. So let's just repeat what we just did in the encrypt, but let's make it into the decrypt, right? So we can do this by essentially converting the cipher text and keys into the numbers from 0 to 25, right? And we do that with our prepared text helper function that we created, right? And then let's do the same thing for the key numbers, where we do the same, almost like it, or exactly like in the encrypt, as you can see up here. And then we need to now we need to now again assert that the key is not empty, because we need that key to produce our results. And we could do that now by doing this, basically just copying that assert or our null check or base case check. That key is in there. And now we could go to our meat of our encrypt, which is going to essentially use that ciphertext number, enumerate over it, almost like in the beginning, right? And then we're going to call collect at the end. Perfect. And now, in order to continue here, let's just make it a bit easier to comprehend by changing the names or the parameters that are passed into this map. And what we need to do now is repeat again the key when it is shorter than the ciphertext. And that's basically saying let key value equal key numbers modulo that key numbers dot length. Nice. Just what we expected. And we now do our decrypt. This is the body or the meat of our decrypt. And that can be written as a variable where we get that decrypted value. And it's essentially just the ciphertext value minus the ciphertext value plus 26 minus our key value modulo 27, 26. Perfect. And now let's go ahead and convert the number back into uppercase, just like we did up here. But I didn't comment that, so let's go ahead and comment that up here, just for the next programmer to understand what we were doing. And then let's say decrypted value plus BA as a character. Cool. And now our Vernam functions should work as expected. And let's go ahead and test it. We have this main function here, so let's go ahead and just create our, our plain text. Be some arbitrary value or string value, and that will just be hello. And our key will just be key for this example. Perfect. And then let's say our encrypted text, we use our Vernam encrypt function. And then let's say our decrypted text be our decrypt function, taking a reference to our encrypted as well as our key. Cool. And then at the end of it, let's just print line for our values here. And that would look like that. And then let's say this is the plain text. Cool. Then we want to pass in our variable plain text. Cool. And then for the next one, we want to then have our key. We pass in our key. Cool. Next one was encrypted, pass in encrypted. Cool. And the next one is decrypted, pass in decrypted. Cool. So let's go ahead and work through this. If there are any bugs, but let's go ahead and use the run function as in this new Rust Rover IDE. Let's see how it works. Looks like we had a few errors. Let's try to find it. Red panicked at 23. Oh, I see. Let's do this. Let's try again. Let's see what happens now. Perfect. As you can see, our plain text was hello, our key was key, and our encrypted value was just some jumbled up nonsense. But our decrypted value was our original message. So great, this works. And just for giggles, I'm going to go ahead and run this with our total CLI. Let's see if it works. Perfect. It works. Great. Now, I'm more than happy to any questions. Like, comment, subscribe if you like the video, and I will see you in the next one. Don't miss our updates on our blog. We're doing a lot of things. We're deep in the crypto space at the moment. We have an Intel market live updates depending on how the market's doing. If it's going up, we have updates. If it's going down, we have updates, and we're doing a lot of intelligence gathering and information gathering and pushing it up to our servers, and we're displaying it for everybody to use. So if you want to see that and follow along, stay tuned. But until then, take care.